Building a new addition on top of an existing underground main service feed may be a code violation. According to the National Electrical Code, the location of service equipment, such as the main service panel, must be accessible. It should also be in a location where damage is unlikely. Constructing an addition directly over the underground service feed can impede access to this equipment. This becomes problematic during emergencies or for routine maintenance. So, covering up the service feed is a potential violation. The configuration of an existing underground feeder with 3 hot wires and 1 ground or neutral wire feeding a 208Y/120 volts, 3-phase, 4-wire main service panel can also be a code violation. The National Electrical Code mandates that a 208Y/120 volts, 3-phase, 4-wire service requires 4 hot wires and a dedicated neutral wire. The ground wire should not be used as the neutral wire. This is a critical safety requirement. To address these code violations, several remedial actions might be needed. Firstly, consider relocating the service equipment. The new location must be easily accessible and not obstructed by the new addition. Secondly, modify the existing underground feeder. This could involve adding a 4th hot wire. Alternatively, the entire feeder might need replacement with a 4-wire feeder. Thirdly, ensure proper wiring by replacing the ground wire with a dedicated neutral wire. The NEC specifies how to properly ground and neutral electrical systems. It is vital to seek guidance from a qualified electrician. They can assess the specific circumstances and recommend the best course of action. They can provide expertise ensuring compliance with local codes and safe electrical practices. A qualified electrician will understand the nuances of the 2017 National Electrical Code and any local amendments that might apply. They will ensure the electrical system is safe, accessible, and compliant with all applicable regulations. Having an electrician review the work ensures that any potential issues are identified and addressed. This includes proper grounding and bonding techniques. The electrician can also verify that all materials and equipment used are listed and labeled for their intended purpose. Remember that electrical work must adhere to the NEC to ensure safety and prevent hazards such as electrical shock or fire. A licensed electrician will be familiar with relevant NEC articles. They include Article 230, which covers services, Article 250, which covers grounding and bonding, and Article 310, which covers conductors for general wiring. The NEC also provides guidance on the proper installation and support of cables and raceways. Electrical systems must be properly sized to handle the intended load, preventing overloads and voltage drops. Working with electricity can be dangerous. It is best to leave electrical work to professionals who have the necessary training and experience. They understand how to work safely with electricity and follow established safety procedures. The National Electrical Code serves as the foundation for safe electrical installations. Its regular updates reflect advancements in technology and best practices. Code compliance is essential for protecting people and property from electrical hazards. In existing buildings, it is common to find outdated electrical systems that may not meet current code requirements. This is particularly true when it comes to grounding and bonding. The NEC has strict requirements for grounding electrical systems to provide a path for fault current to return to the source. This helps to protect against electrical shock hazards and prevent equipment damage. Bonding is another important aspect of electrical safety. It involves connecting all metal parts of the electrical system together to create a low impedance path for fault current. This helps to ensure that circuit breakers and fuses operate properly in the event of a fault. A qualified electrician can evaluate an existing electrical system. They can determine if it meets current code requirements and recommend any necessary upgrades or repairs. This may involve replacing outdated wiring, installing new grounding and bonding systems, or upgrading the service entrance. When performing electrical work, it is important to use the right tools and equipment. This includes insulated tools, voltage testers, and personal protective equipment such as gloves and safety glasses. Always to energize circuits before working on them, and verify that the circuit is dead using a voltage tester. It is also important to follow proper lockout-tagout procedures to prevent accidental energization of the circuit. Working with electricity requires knowledge, skill, and attention to detail. It is not a job for amateurs. Always hire a qualified electrician to perform electrical work to ensure that it is done safely and correctly. They will be able to identify potential hazards and take the necessary precautions to protect themselves and others. The cost of hiring an electrician is a small price to pay for peace of mind. The NEC requires that electrical work be performed in a neat and workmanlike manner. This means that wiring should be properly supported and secured, connections should be tight and clean, and all equipment should be installed according to the manufacturer's instructions. Sloppy electrical work can be a safety hazard and can also lead to premature equipment failure. Inspectors look for these issues during electrical inspections. If the electrical work does not meet code requirements, the inspector may require it to be corrected. This can be costly and time-consuming, so it is best to do the job right the first time. The National Electrical Code is a comprehensive document that covers all aspects of electrical installations. It is important for electricians to stay up to date on the latest code changes to ensure that their work meets current requirements. The NEC is revised every 3 years. There are also regular interpretations and clarifications issued by the NEC. These provide additional guidance on how to apply the code in specific situations. Electricians can attend training courses and seminars to stay up to date on the latest code changes and interpretations. They can also subscribe to industry publications and online forums to stay informed. The 2017 NEC addresses the safe installation of electrical systems in various types of buildings and structures. It covers topics such as wiring methods, overcurrent protection, grounding, and equipment installation. The code also includes requirements for specific types of equipment such as transformers, generators, and solar photovoltaic systems. The NEC is not a design manual. It provides minimum safety requirements for electrical installations. Electrical engineers and designers use the NEC as a basis for their designs. They also consider other factors such as energy efficiency, reliability, and cost-effectiveness. Electrical installations should be designed to meet the specific needs of the building or structure. The design should take into account the expected load, the type of occupancy, and the environmental conditions. The NEC requires that electrical equipment be listed and labeled by a recognized testing laboratory. This ensures that the equipment has been tested and certified to meet safety standards. Listed equipment is typically marked with the testing laboratory's logo. The listing mark indicates that the equipment has been evaluated for specific hazards such as electrical shock, fire, and mechanical hazards. Electrical equipment should be installed according to the manufacturer's instructions. This is important for ensuring that the equipment operates safely and reliably. The manufacturer's instructions typically include information on the proper mounting, wiring, and grounding of the equipment. It is important to follow these instructions carefully to avoid damaging the equipment or creating a safety hazard. The NEC requires that electrical systems be inspected and approved by a qualified electrical inspector. The inspector will verify that the electrical work meets code requirements and that the system is safe to operate. Electrical inspections are typically required for new construction, renovations, and additions. The inspection process may involve a visual inspection, testing, and verification of documentation. If the electrical work does not pass inspection, the inspector will issue a correction notice. This notice will list the code violations that need to be corrected. The electrical contractor is responsible for correcting the violations and arranging for a re-inspection. The electrical system cannot be energized until it passes inspection. The NEC covers the installation of electrical systems in hazardous locations. Hazardous locations are areas where flammable gases, vapors, or dust may be present. These locations require special electrical equipment and wiring methods to prevent explosions and fires. The NEC classifies hazardous locations into different zones based on the likelihood of a hazardous atmosphere being present. Each zone has its own specific requirements for electrical equipment and wiring. Electrical equipment used in hazardous locations must be explosion-proof or intrinsically safe. Explosion-proof equipment is designed to contain any internal explosions and prevent them from igniting the surrounding atmosphere. Intrinsically safe equipment is designed to limit the amount of energy available so that it cannot ignite a hazardous atmosphere. The NEC also includes requirements for the installation of fire alarm systems. Fire alarm systems are designed to detect fires and alert occupants so that they can evacuate the building. The NEC specifies the types of fire alarm devices that are required in different types of occupancies. It also includes requirements for the wiring, power supply, and monitoring of fire alarm systems. Fire alarm systems must be inspected and tested regularly to ensure that they are operating properly. The NEC includes requirements for the installation of emergency lighting systems. Emergency lighting systems are designed to provide illumination in the event of a power failure. This helps to ensure that occupants can safely evacuate the building. The NEC specifies the amount of emergency lighting that is required in different types of occupancies. It also includes requirements for the wiring, power supply, and testing of emergency lighting systems. Emergency lighting systems must be inspected and tested regularly to ensure that they are operating properly. The NEC also addresses the installation of standby power systems. Standby power systems are designed to provide power to essential equipment during a power failure. This may include equipment such as fire pumps, life support systems, and communication systems. The NEC specifies the types of equipment that are required to be connected to standby power systems in different types of occupancies. It also includes requirements for the wiring, power supply, and testing of standby power systems. Standby power systems must be inspected and tested regularly to ensure that they are operating properly.